So using the graph from number 8, let's evaluate the function at these x values. So f at -4. Now these are x values, so -4 when we're looking at number 8. All right, let me clean this up a little bit. Okay, so let's look at an x value of -4. So here's the x value of -4, and I see that at this x value, the function is here. Basically, the y value is 5. So that's going to be the value of the function at -4 is 5. So basically, you're given an x value, and you're being asked for the y value that goes with it. What about -2? What's the value of the function at -2? So be careful here, because -2 is the point where it changes from blue to red. So I have to stop and think, is it going to be the blue or the red? Because they both seem to be at -2. But the open circle doesn't count. All right, that open circle means that point is not included. So really, it's just this point, which has a y value of 1. So at -2, the value of the function is 1. And finally, what about 6? All right, if I go over to an x value of 6, then I see the function is down below. It is right here. And the y value of that is -3. So at 6, the value of the function is -3. All right, so that's how you can evaluate based on the graph. All right, in this video we are going to evaluate these piecewise functions for various values of x. So please pay attention to what variable of the function that you have. So for example, number 11, this p refers to function p. So make sure you're using the correct function for the correct problem. So look at function p. We have 3 pieces, 0, -2, and -4. So that's sort of like y equals 0, y equals -2, and y equals -4. The domain restriction part of the function will tell us which one of these 3 pieces to use. So our x value is -1. Is -1 less than -6? No. So we're not using the top part. Is -1, is -6 less than or equal to -1, which is less than 1? Well, -1 is not less than itself. So no. It's going to be the bottom piece that we're using, because -1 is greater than or equal to -1. Because of the or equal to, that makes this bottom part true. So we're going to use the bottom. So now looking at this y equals -4 part, there's nothing to plug into. It's just a constant. That means the answer is simply -4. Okay, let's do that 3 more times. So for the next function, we're supposed to be using function j. See the j? That's this j, so we're using this function. Now -3. Is -3 less than -1? Well, yes it is. So that tells us that we're using the top part. So we have -2x plus 4. Okay, that means we have, since x is going to be -3, that means we have -2 times -3 plus 4. Negative times negative is a positive, so that's going to be 6 plus 4, which of course is 10. So the answer to that one is 10. All right, let's do that again. Let's reset. Okay. The next one, again, we're using function j, not function p. So 0. Is 0 less than negative 1? No. Is 0 greater than or equal to negative 1? Yes, 0 is greater than negative 1. So that means we're using the bottom function. That means we're doing x minus 2. All right, if x is 0, that means we have 0 minus 2, which is just negative 2. All right, last one. Function j again. All right, so most of these are function j. Negative 1. Notice that both of these domain restrictions involve the number negative 1. But we're going to pick the one that says or equal to negative 1. All right, because obviously negative 1 equals itself. So that means we're using the x minus 2 version part of this function. If x is negative 1, then that makes this negative 1 minus 2, which is negative 3. All right, that's going to do it for this video. It's just a quick one. I hope it was helpful. I will see you on the next video.